Okay, guys, welcome. Today we're going to talk about integer exponents as a whole, and specifically we're going to focus on exponents that are 0 or negative. Okay, so the two rules that involve um, negative exponents and 0 exponents are the following. So quite simply, if you have any real number a that's not equal to 0, basically anything to the 0 power is always going to return 1, right? And of course, as long as a is not 0, if you have 0 to the 0, that's sort of an indeterminate form, which we won't really discuss too much. But for the most part, we're going to assume that everything to the 0 power is 1. Okay. Now, if you have a negative exponent, right, what happens there is that you're going to move it, if it's in the numerator, to the denominator, and then it becomes positive. And then, of course, if it's in the if the negative exponent is in the denominator, then we move it to the numerator and make it positive, right? So it's not necessarily that a negative exponent causes you to flip the number, but you're going to move it from numerator to denominator or denominator to numerator. Okay, so for these examples, these are all going to be fairly quick because for part A, we have 3 to the 0, and anything to the 0 power is 1. For part B, we have negative 4 to the 0. That's also 1. Part C, we have 2/5 to the 0, and that's also 1. All right, so those first three are straightforward. Now in part D, we have 4 times xy to the 0. Right, now the 0 is only attached to the xy, so that's the only part that's going to become 1. Right, but we still have this 4 from before. So then we have 4 times 1, which of course is 4. In part E, we have negative 2 over t squared minus 1 to the 0. And in this case, the denominator, of course, we're going to assume that t is not 1 or positive 1, so we don't have any issues there. And this, of course, would give us negative 2 over 1, which is negative 2. Okay, now last but not least, part F is negative 3 to the 0. And here you have to be extremely careful, right? Now the 0 is only attached to the 3. It's not attached to the negative here. So here you have to bring the negative through, and only the 3 to the 0 is going to become 1 there, right? So this negative has to come through because there's no 0 exponent attached to it. All right, so you have to be a little careful there. Okay, let's do some examples that involve negative exponents. So in part A, we have 3 to the negative 2. All right, well, we saw from before that if we have something in the numerator, that's going to go to the denominator and then become positive. So this is 1 over 3 squared, which is 1 over 9. In part B, we have 1 over 2 to the negative third. I believe it's supposed to be like this. All right, so now since it's in the denominator, this is going to come up top. We're going to get a 2 to the third, and that's just equal to 8. Right? Part C, we have negative 3 to the negative 2, and the negative 2 exponent is attached to both of these since it's in parentheses. So this is going to become 1 over negative 3 squared, so 1 over a positive 9. Okay, now part D is when we have to be careful because that negative exponent is only attached to the x here. So we're still going to have a negative 1 up top, and then x to the 7th is going to go in the denominator. Okay, part E, we have negative 2 over a minus 1 to the negative 2. So we need to bring the a minus 1 up top. That's become a minus 1 squared. So we just get, and I guess we could even just leave this one like this, right? We could always FOIL out a minus 1 and continue forward, but just the idea of the negative exponents is what I want to emphasize here. Okay, now in part F and part G, we sort of get those closely related problems, right? Now part F, the -3 exponent is attached to both the 2 and the x. So this is 1 over 2x to the +3. So this is going to be 1 over 2 to the third x to the third, so 1 over 8x to the third. Right? Now in part G, the -3 is only attached to the x, right? So this is 2 over x to the third, and that's all we can do with that one. All right, so just note the difference between these two. Although they look very similar, you get very different answers here. All right, so just be careful there. Okay, and then part H, we have a plus b to the -5th, right? And a I can't do anything with, but b to the 5th I can make 1 over b to the 5th. Right, and of course, if you wanted to, you could find a common denominator and add those two together, but we'll leave this as a plus 1 over b to the 5th. Okay, so now let's do a couple examples where we're going to fully simplify everything that we have, given the rules that we have so far. So in part A, we have 4a to the third over 6a to the -5th. Well, the 4 over 6, again, we just sort of work on this piece at a time, we can make 2 over 3. And if we look at the a's, we have a to the third, and then a to the -5th is going to come upstairs and become a to the +5. So now if we combine the two a terms, we're going to get 2/3 times a to the 8th. Okay, part B. And I should mention here that we could say that this is 2/3 just times a to the 8th as well. Both of those are equivalent. All right, so if you see that written somewhere, they are indeed the same thing. Now for part B, we have x squared y to the -3rd all to the -5th. All right, so now here what we can do is we can apply our product to an exponent rule, right? So in slow motion, I have x squared to the -5th, y to the -3rd to the -5th, right? And then this will become an x to the -10 times y to the +15. So then once we move the 10 down below, I'm going to get y to the 15 over x to the 10th. Right? Now, that's not the only way you could have done this. You could have also simplified the inside first. You could have said this is x to the third over y to the +3rd to the -5th, and then apply your exponents there. Or you could even say that this is 1 over x squared y to the third to the 5th, which is equivalent to saying y to the third over x squared all to the 5th, right? Regardless of how you do it, you're going to end up with y to the 15th over x to the 10th. So a couple different ways you could do a couple of these. Now in part C, we have a to the -3rd times a squared over b to the -2 all to the 4th. So I guess let's take care of our negative exponents first. And we'll first say this is, we'll say 1 over a to the third. And then the parentheses will become a squared b to the +2, because we'll bring that up top, and then all to the 4th. So we have 1 over a to the third times, this will become a to the 8th and b to the 8th. So then if we simplify our a's, we're going to get a to the 5th, b to the 8th. All right, so those are a couple examples on simplifying. All right, so just to summarize all of our rules that we have so far, we have the rule that if we multiply two numbers with the same base, we add their exponents. We have the fact that if I take a over b and raise that to the n, I could just have easily said that that's equal to a to the n over b to the n. Here's your division rule, right? So if you take a to the m over a to the n, basically you're subtracting the exponents, right? Anything to the 0 power is 1. This says that if I take a number raised to a power and raise it to a further power, then I multiply the exponents. My rule for negative exponents say that if I have a negative exponent, I'm putting it in the denominator if it's in the numerator, or the numerator if it's in the denominator, and making it positive. And then, of course, last but not least, we have that if I take a product and raise that to an exponent, I can take the product of each raised to that exponent. Okay, so that concludes this video on integer exponents as a whole. I hope you enjoyed, and I will see you next time.